Okay, this is our video for Chapter 7, Lesson 4. This lesson is called Scale Drawings, but really it should be called Scale Drawings and Scale Models. Here I have a couple examples of scale drawings or scale models. I'll start off with a map. A map is a scale drawing. It is drawn to scale, which means that it is drawn proportionally to the actual United States of America. In this little box, you'd be able to find the map legend. It's very small, but it's right here, and it tells you the scale used to create the map. This is a scale drawing of a grasshopper. It tells us the scale is 2 to 1. That means our model is 2 times as big as what the actual grasshopper would be. This is a Matchbox car. Some of you may have some of these at home. A Matchbox car is a model, not a drawing, because it is 3D. This model is made to scale with the actual car. This would be an Audi R8. It's made to scale, meaning it's proportional to the actual Audi R8. A lot of math goes into making scale drawings and scale models. Let's talk about some of that math. First thing, we're going to do a little bit of vocab. Scale models and scale drawings, these are replicas or reproductions, and they are made to be proportional to the original object, meaning that there's a lot of math that goes into creating them. As with proportions, we use cross products to solve these types of problems. And then we have another new word here. This is scale factor. The scale factor is the ratio used to create that model or that drawing. Let's look at a practice problem. Number 1, a scooter is 3.5 feet long. This is the real life measurement of a scooter. Find the length of a scale model of the scooter if the scale is 1 inch equals 3/4 of a foot. First thing you have to remember, model over real. We are always going to put the model length on top, the real length on the bottom. So we're going to take the scale right here, and we're going to write it as a ratio. 1 inch, that's our model length, equals 3/4 feet. That's our real length. And what that means is for every 1 inch in the model, it'll be 3/4 feet in real life. So here is my first ratio. That is the scale. Then we write our proportion out, and we have to determine where 3.5 feet goes. Now remember, this is the real life measurement of a scooter. So our ratio is model over real, which means our 3.5 feet will go down in the denominator with the real life measurements. Another way you can check if you put it in the right spot is that your units of measurement will line up, feet and feet. Here I have to solve for the model length, so I'm going to use a variable. I'm choosing to use the variable x. You can use whatever you want. To solve for x, we are going to cross multiply. First, we start off with the multiplication problem that has our variable. 3/4 times x is 3/4 x. Bring down your equal sign. 1 times 3.5 is 3 1/2. Drop your train tracks into place. We need to isolate the variable, so I'm going to divide both sides by 3/4. This gets me 1x on the left-hand side, and over here I have to do a little bit of margin work. Change my mixed number into an improper fraction. 3 times 2 is 6, plus 1 is 7. Divided by 3/4. 7 times 4 is 28. 2 times 3 is 6. And we know that's an improper fraction. So just a reminder, you're going to drop the 28 into the house and see how many times 6 goes into 28 evenly. It goes in 4 times with a remainder of 4. And 4 becomes my numerator, and 6 is still my denominator. So I get 4 4/6 down here in my solution. But we're not happy with that because we can simplify. We'll divide by 2, and we get 4 2/3. Now you need to know which units go with that answer. Is it inches? Is it feet? A couple ways we can figure that out. First of all, we know we're solving for the model length. So the model is going to be in inches. The other way we can do this is to look at where our variable is. Our variable's here in the numerator, and that's aligning with our inches as well. So either way, we know that we are using inches in our final answer, 4 2/3 inches. Number 2, Mrs. Watts assigned you a project to create a scale drawing of your bedroom. She is suggesting to you that you use the scale 2 inches equals 3 feet. So we're going to write that down, model over real, 2 inches in the drawing equals 3 feet in real life. Okay, get that down on your paper. So you go ahead and you do your drawing, and it turns out that the width of your bedroom is 15 inches in the drawing. Your job is to find the actual width of your bedroom. So I'm not going to do this problem for you, but I'm going to give you a couple hints. Remember, it goes model over real. So you need to figure out where the 15 goes in the numerator or the denominator. I'll give you one more hint. Line it up with the same units. Then you can cross multiply and figure out the actual width of your bedroom. Number 3, this is the last problem that we will do together. Find the scale factor of a model sailboat if the scale is 1 inch equals 6 feet. So again, we do model over real, 1 inch equals 6 feet. But this time the question has changed a little bit. We're not looking to find a missing measurement. We just want to know the scale factor. And the scale factor is this. It's when we turn our units into the same unit of measurement. Right now we have inches in the top, feet in the bottom. Turn it into the same unit, simplify our ratio, and write it as a very plain, simple ratio in simplest form. That tells us the link between the model and the real life measurements. So we start off with inches over feet, but remember what I said, we really want this to all be the same unit. So it's much easier to turn a larger unit into a smaller unit. We use multiplication to turn feet into inches. Turning inches into feet uses division. That's going to be hard. That's going to get us a decimal. So let's change our 6 feet into inches. To do that, we're going to multiply by 12 because there are 12 inches in a foot. And now we get 1 inch over 72 inches. So all we did was we converted 6 feet into inches. Now that we have this ratio, 1 inch over 72 inches, we can cancel out our inches and write our scale factor as a plain Jane ratio. What this means is that the model sailboat is 1/72 the size of the actual sailboat. So if we have a sailboat here in real life, this is a really poorly drawn sailboat, 72 little itty bitty model sailboats could be placed end to end and equal the same as the length of a real sailboat. Don't worry, we'll talk more about this tomorrow, but just remember the steps are get it to the same units. Once you have the same units in the numerator and denominator, you can cancel them out, and that means that this ratio is the scale factor. That's all for today. Here's your assignment. Finish number 2 on page 7, do number 4 on page 7, do your Google form, and add to your vocabulary cards. We got new words today, scale model and scale drawing, and scale factor.